In this video, we'll be going over the bottom-up array approach of edit distance. So previously, in the 2D bottom-up matrix approach, in each of the iteration, we can see that we are only relying on values from rows I plus 1 and I. This means we can use a single array to represent our 2D matrix. So let's go over the thought process. So in the 2D bottom-up matrix approach, and in each of the iteration, we are only relying on values from the row I and I plus 1. This means we can represent our 2D matrix using a single array. Then in each of the row operation or the row iteration, we will be updating the values from the previous row iteration. Now let's go over a pseudocode. So we're going to create an array, min_ops. Then we're going to iterate through the indices from word1.length to 0, denoted as I. Before that, we're going to create a variable, prev, to keep track of the value, to keep track of the previous value that was located at I plus 1 and j plus 1. Now, then we're going to iterate through the indices from word2.length to 0 to know as j. If I and j are out of bound, that means we have no more operations left. If I is out of bound, this means the rest of the operation is going to be insertion. But before we move forward, we're going to set previous to the current number of operations. So it's min_ops j before we replaced it. Then if j is out of bound, then the rest of the operation is going to be deletion. So we're going to set prev to the current number of operations before we have replaced it. And then we're going to update min_ops j to the number of characters we need to delete. And then we're going to create a variable, current, to keep track of the current value before we replace it. Then if two characters are the same at I and j, that means we want to find the minimum number of operations by moving both pointers forward, which is min_ops j to prev. As you can see here, we create a variable prev to keep track of the previous value that was located when we moved both pointers forward. So we're going to set min_ops j to prev. Else we're going to find the minimum number of operations from the 3 type of operations that we are allowed to use. And when we move both pointers forward, I plus 1, j plus 1, this is the previous value before we have replaced it. And min_ops j plus I plus 1, that means is the value at the current cell. So min_ops j. And also min_ops j plus 1, this means we are at the current row, but to the cell to the right. That means we can just do min_ops j plus 1, incremented by 1 to account for the current operation. And then we can return min_ops starting from 0. From indices 0. Now let's go over the time and space complexity. Time complexity stays the same because of our nested for loop, and our space complexity changes to n, where n is the length of word2, and is the array, min_ops array. Let's go over the code. So we are going to convert our min_ops to an array. Then we'll iterate through. Then we're going to create a variable prev to keep track of the value at I plus 1 and j plus 1 that before we have replaced it. It will initially be equal to 0. If the both pointers are out of bound, we can just continue to the next iteration because there are no operations that we need to use. Now if I is equal to word1.length, that means the rest of the operations insertion. But before we insert our characters, we need to keep track of the number of operations at the current cell. And we'll also do this for the next one when we need to perform deletions. And then before we update the values here, we need to save it. Oh, before this, there's one more thing. We're going to set previous to current, because we need to keep track of the previous value before we have replaced it. Then we're going to create a variable current and save the current number of operations. if the two characters are the same, that means we need to find the minimum number of operations by moving both pointers forward. And then else we need to find the minimum number of operations from the 3 types of operations that we're allowed to use. So when we move both pointers forward, it's going to be equal to prev. And then when this is I plus 1, that means we're at the current cell. And then if it's I and j plus 1, that means we're at the current row but to the right, so it's just min ops I. I should reduce this now. And then we're going to update our previous to the current value. And then we'll return min operations starting from indices 0. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview. I upload videos every day, and if there are any topics you want me to cover, let me know in the comment section below.